In the previous lecture, we have been talking about the theoretical background as far as SHA-256 algorithm is concerned, and in this lecture we are going to implement it from scratch in the sense that we are going to use the built-in libraries of Java in order to produce the SHA-256 hash. So first of all, we create a public static. It is going to return with a string, so basically the 64 character long SHA-256 hash itself. So the name of the method is hash, and of course we get the data itself. So what do we want to do? First of all, let's create a try catch block. So we have the try, and we will catch any kinds of exceptions. And of course, whenever we catch a given exception, we throw a new runtime exception. So this is the try catch block. And otherwise, what do we have to do? First of all, we have to instantiate a so-called message digest. This class is present in Java security package. Okay, so we have the digest, and then we can use the static class, the so-called getInstance, and here we have to define the algorithm we would like to use. And of course, we are after the SHA-256 hashing algorithm. Okay, so this is how we can get an instance of SHA-256. Then we are going to get a one-dimensional array of bytes, the so-called hash, which is equals to the digest, and we have the digest method as well. First of all, we have to use the data because of course the data is the string we would like to transform into a 64-bit long hash. So we have the so-called get bytes, and we have to define the character set. In this case, we are using UTF-8. You may pose the question that what is this UTF-8? It stands for Unicode Transformation Format with 8 bits, hence the name UTF-8. So this is a variable with character encoding used for electronic communication. Okay, so there are quite good examples present on Wikipedia. In this lecture, we are going to focus on SHA-256 hashing algorithm. So first of all, we have to get an instance of SHA-256. Then we have to get the bytes, and the character encoding is UTF-8, and this is how we get a one-dimensional array of bytes. But of course, the problem is that we would like to end up with hexadecimal values instead of bytes. So what do we have to do? First of all, we instantiate a string buffer because we are dealing with strings, and if we want to make sure that it is going to be efficient, so all the operations will be as fast as possible, then it is advisable to use string buffer. So first we have to iterate through all the bytes. So we have integer I is equals to 0, then we have I is less than the hash.length. So basically we are going to iterate through the byte one-dimensional array one by one. Then we have plus plus I, okay. First of all, we have to transform the bytes into hexadecimal representation, but the problem is that bytes are signed in the sense that it may contain negative values as well. But of course, we want to make sure that we are not going to store negative values, because if we want to convert the values into characters, because we are after a string representation of the hexadecimal hash, then of course negative values doesn't have any character representation. So what do we have to do? We have to use integers to hex strings. So basically we transform the bytes into integers first of all, and then the integers into hexadecimal strings, and this is how we can end up with the hexadecimal string representation. Of course, on a one-by-one basis. So we are going to transform the first byte into a string, then the second byte into a string, and we are going to concatenate these strings. And you may pose the question that, okay, why do we have to use something like this? And this is exactly what we have been talking about. Bytes can store negative values as well, and with the help of this transformation, we transform negative values into positive ones. So for example, if we use -5, then we have the AND logical operator and this hexadecimal formula, then we end up with 251. So basically 256, which is 2 to the power of 8, minus 5, which is equals to 251. So this is how we can make sure that we are not going to end up with negative values, because we would like to transform the integer into hexadecimal string representation. And finally, we are going to append the given hexadecimal representation to the string buffer. So this is how we keep building the final string on a one-by-one basis. We keep considering all the bytes one by one, and this is how the algorithm is going to get the final result. So after the transformation, we return with the hexadecimal string, and of course we have to call the toString method in order to transform the string buffer into a string. And of course, sorry for that, we have to do it somewhere here. Okay, so that's all about the SHA-256 algorithm. So if we save it, then of course we can use it here. So system out and println, we can use SHA and 256 helper because this hash function is static. And if we use the hello world, so something like this, then we save and run the application, then as you can see, we end up with something like this. It is a 64 character long hexadecimal string that's going to represent the input. Of course, if we are dealing with blockchains, then the input will be the nodes. So a single node of the blockchain will be the input and the output will be a 64 character long hexadecimal representation. Let's take a look at the main features of hashing. We would like to make sure that this algorithm is deterministic. So if we apply the same hash function on the exact same input, then the output must be the same. Of course, if we use the same input, so we save and rerun the application, then of course the result will be the same. So if the inputs are the same, then of course the outputs will be the same. But if there is a minor change in the input, so for example we say hello and instead of hello we use hell word, then these strings are very similar to each other. But if I save and run the application, then as you can see the output will be completely different. And this is one of the fundamental characteristics of hash functions, that if we make a little change in the input, then the output will change dramatically. And of course it is an extremely powerful feature of hashing because we are not able to guess these hashes based on very similar inputs. It is called information leaking in cryptography, which means that SHA-256 algorithm doesn't have information leaking. We are not able to approximate the input based on the outputs. By the way, Bitcoin uses double hashing. What does it mean exactly? That we use SHA-256 and then we use it again. So basically, if we use something like this, hello world, I am going to get rid of these. If we save and run it, then of course the output again is a 64 character long hexadecimal string. But as you can see, we have used SHA-256 on hello world, and then the output will be the input of another SHA-256 algorithm. And this is how we can end up with double hashing, and this is what Bitcoin uses under the hood. We are going to assign a hash value to every single block within the blockchain. This is how we can identify all of the blocks. So these hashes are going to be the identifier of the blocks, and there are hash pointers. So it is a linked list data structure where the references are hash pointers. Okay, so this is how we can achieve hashing. Thanks for watching.